Bismillahirrahmanirrahim. Welcome to the class of Introduction to Logic and Critical Thinking. I'm your instructor Ali Ahmed from Southern Business School, University of Southern Punjab, Multan. Dear students, in our previous discussions, we learned that categorical propositions are the statements that relate two classes or categories. For example, all dogs are mammals or some birds are not flightless. Each of these propositions has a subject term and a predicate term that are connected together by a copula or a bridging word, such as are or are not. Today, we will take this understanding a step further by exploring how these propositions are related to each other logically. This brings us to an important concept in traditional logic known as the square of opposition, followed by a look at further immediate inferences we can draw from these categorical statements. The traditional square of opposition is a diagram that shows the logical relationships among the four basic types of categorical propositions. These are the A proposition, that is the universal affirmative, all S are P. For example, all cats are mammals. Then comes the E proposition, that is universal negative in the nature. For instance, no cats are reptiles or no S is P. Then comes the I proposition, that is particular affirmative, some S are P or some cats are black. And finally, we are coming a long way to the final proposition, that is the O proposition, particular negative in the nature, some S are not P, that is some cats are not white. These four propositions are placed at the corners of a square to show how they oppose or relate to each other. There are four main relationships represented in the square of opposition: contradictory, contrary, subcontrary, and subalternation. Let us discuss the very first one, that is the contradictory relationship. This is the strongest type of opposition. Two statements are contradictories when they cannot both be true and cannot both be false at the same time. The contradictory pairs are A and O. A actually is all S are P and O is some S are not P. And then E and I. For example, if all dogs are friendly is true, then some dogs are not friendly must be false. If no birds are mammals is true, then some birds are mammals must be false. However, if one of these pairs is false, please mind it, if one of these pairs is false, the other must be true. Then comes the second relationship, that is contrary relationship. Contraries are the propositions that cannot both be true but can both be false. The contraries are A and E. For example, it cannot be true that all fruits are sweet and no fruits are sweet at the same time. However, both can be false. Perhaps some fruits are sweet and some are not. Then comes the third kind of relationship, that is the sub-contrary relationship. Sub-contraries, dear students, are the opposite of contraries. They cannot both be false, but they can both be true. The sub-contraries are I, some S are P, and O, some S are not P. Let us clear this very particular relationship with an example that some people are honest and some people are not honest can both be true, because honesty varies among individuals, but they cannot both be false. If it is false, then some people are honest. It would mean that no people are honest, which makes some people are honest as true. And finally, there is a fourth kind of relationship that is referred to as the subalternation relationship. Subalternation deals with the relationship between the universal and the particular statements of the same quality, that is affirmative or negative. The A, that is universal affirmative, implies that I, that is particular affirmative. The E, that is universal negative, implies the O, that is particular negative. For example, if all cats are mammals is true, it must follow that some cats are mammals is also true. If no fish are birds is true, it must follow that some fish are not birds is true as well. However, the reverse does not necessarily hold. If some cats are mammals is true, it doesn't necessarily mean that all cats are mammals is true. Though in this particular case, it happens to be logically the implication, it happens to be, the case, but logically the implication does not go that way. Now there are some limitations of the traditional square of opposition as well. It is important to note that the traditional square of opposition assumes that the subject terms refer to existing things. For instance, if we say that all unicorns are white, this might appear true, but it assumes that unicorns exist, which they do not. In modern logic, we drop this assumption often and only use the contradictory relationships as those do not depend on the existential import. Nonetheless, the traditional square remains useful for understanding the classical reasoning. Now that we have explored the relationships between the propositions in the square of opposition, let's turn to further immediate inferences. An immediate inference is a logical operation that allows us to derive a new proposition directly from a single given proposition, not from a syllogism or multiple premises actually. The three most common types of immediate inferences are conversion, obversion, and contraposition. Conversion means switching the subject and the predicate of a particular proposition. For example, from no dogs are cats, we can infer that no cats are dogs. However, not all propositions can be validly converted. Let's look at the rules. E propositions, that is no SRP, convert simply into no PRS. For instance, no students are teachers would be able to be converted into no teachers are students, that is valid. Then comes the I proposition. It is also converted simply like the original I proposition is some SRP and it will be converted as some PRS. For example, some doctors are women and some women are doctors, again valid. Then comes the A proposition, that is all SRP, and the O proposition, that is some SR not P, do not convert simply. However, the A propositions can be converted per accidents, that is, it can be converted into a particular statement. For example, all cats are mammals, some cats are mammals, valid, but it is not, that much convertible like the other statements are. The upper position does not allow valid conversion at all. Then comes the case of obversion. Obversion is an inference where we can change the quality of a proposition from affirmative to negative or vice versa, and replace the predicate with its complement class or the opposite class. This transformation is always valid for all four types of propositions. Now there are some rules for obversion, that is changing the quality from affirmative to negative, replacing the predicate with its complement, that is the non-predicate, non-P. For instance, all dogs are mammals, and it would be obverted into no dogs are non-mammals. For instance, the case of E, no cats are reptiles would be obverted into all cats are non-reptiles. In the case of I, some birds are singers would be obverted into some birds are non-singers, are not non-singers. And then comes the case of the O, that is some fish are not blue would be obverted into some fish are non-blue. Obversion is perhaps the simplest and the most universally valid of all three immediate inferences. Then comes the contraposition, that is it involves basically two steps. The very first step is to switch the predicate and the subject, and finally to replace both of the classes with their complement classes. Contraposition is valid for A and O propositions only. For example, all dogs are mammals. It would be contrapositioned into all non-mammals are non-dogs, which is valid. Then comes the O proposition, that is some animals are not mammals would be contrapositioned into some non-mammals are not non-animals. Again, it is valid. However, E and I propositions do not, do not contrapose in a valid kind of a situation. So in summary, in today's lecture, we learned that the square of opposition provides a map of how the four types of categorical propositions relate to one another through contradiction, contrary, subcontraries, and subalternation. Meanwhile, immediate inferences such as conversion, abversion, and contraposition show like how we can derive new statements from the existing ones. Together, these tools are the foundational, kind of things for reasoning and argument analysis in the logic. They help us test to, understand the consistency of our belief, evaluate statements critically, and avoid drawing invalid conclusions. Understanding these relationships helps us and prepares us for more advanced topics such as syllogistic reasoning, which builds upon these single statement inferences to form multiple arguments. Thank you, dear students. That was all.